We'll talk about climate models. How good are they, and what do they tell us about the future? We'll look at simulations like these. Each of these color curves is an attempt to replicate the global mean temperature by a different climate model going back over the last 100 years. The black curve shows what actually happened, and so the climate models are largely successful in replicating that. We can run those same models again, but without putting in the increase in greenhouse gases and sulfate aerosols, and we get this set of curves down here, which is okay for the first 50 years of the 20th century, but begins to diverge from the actual record in the latter part of the 20th century. This is but one piece of evidence that man is affecting climate. We can look at what climate models predict about the future, given particular scenarios. In this case, scenarios labeled by B1, A1B, A2, etc., about how emissions themselves might change over the next few hundred years. We'll talk about these projections, our confidence or lack of confidence in them, and what they mean for us. Finally, we'll talk about consequences. What happens when the climate changes? For example, one problem is that ice melts. This is a diagram based upon very carefully calibrated satellite-borne laser observations of the altitude of the ice sheet in Greenland, where a lot of the world's fresh water is locked up, showing the change in ice altitude between 1989 and 2005. Well, actually, the ice has been getting thicker in the interior of Greenland here, but thinner along the margins. Measurements since this time have actually shown that there's a net loss of ice mass in Greenland that can only lead to an increase in sea level. We'll look at the consequences and the observations of changes in the distribution of precipitation. So this map shows the observed trend in precipitation in Europe between 1961 and 2006. The oranges and reds show declining precipitation. The blues, such as up here in northwestern Russia and Scandinavia, show increasing precipitation. We can compare that to the predictions of climate models shown by the inset, where reds in this case show declining precipitation and blues show increasing precipitation. What does that mean? Is this going to continue going forward? What are the effects of these kinds of changes in rainfall around the world? We'll look at climate extremes like heat waves. This is a diagram showing the temperature anomaly and heat stress accompanying a big heat wave in the summer of 2003 in Europe, which is estimated to have killed about 35,000 people. Are heat waves like this becoming more common? Do we expect them to become more common? If they do, what's the implication of that? My own work focuses on hurricanes, and we have evidence in the Atlantic, where we have exceptionally good records of hurricanes, that hurricane power, shown here by the green curve, is changing in concert with the temperature of the tropical Atlantic in summertime, shown by the blue curve. This goes all the way back to 1870. It shows profound oscillations in the temperature, but a net increase in hurricane power over this time. Is that going to continue? Why is it happening in the first place, and what are the consequences of that? Here is a map estimating storm surge risk in New York. Today and after 100 years, when sea level will have risen, we estimate by 1 meter. So even if the storms of the future don't change, the fact that storm surges, which are a very destructive component of storms, such as occurred in Hurricane Sandy in 2012, will be more destructive simply because they're riding on top of an elevated sea level. Another problem to look at is the increasing acidification of the ocean. This is a direct effect of carbon dioxide and would be there whether or not the climate changes. Much of the carbon emitted in the atmosphere is absorbed by the oceans. That decreases their pH, increases their acidity. What are the implications of that increase in acidity for marine life like plankton and corals? In the next section of the course, I'll give you a brief overview of the physics of our climate system.